Previously, we have graphed linear inequalities, and all the inequalities were in slope-intercept form. So they were already ready to graph, we knew what to do, and we went with it. Today, we're going to graph linear inequalities, but they're going to start in standard form. So this just means we have a little bit of manipulation we have to do before we're ready to graph. So here are your steps. Follow these every time. So you're going to take that standard form and you're going to convert it to slope-intercept form. Once you change it to slope-intercept form, it's exactly what we did before. You're going to graph the line, make sure you pay attention to whether it needs to be a solid or a dashed line. You're going to pick a test point to see which side of the line you should shade, and then you're going to shade the right side of the line, or the appropriate side of the line. Now, we have converted from standard form to slope-intercept form before, but it's been a while, so pay attention to the steps, and this is how it's done every time. So we're trying to change to slope-intercept form, so we're trying to isolate y. So I have 2x plus 7y is less than or equal to negative 7. I need to isolate y, so I'm going to subtract 2x from both sides. That gives me 7y is less than or equal to negative 2x, write that x term first, minus 7, so that it's in slope-intercept form. Now, to isolate y, I have 7 times y, so I need to divide by 7, but remember that you divide every term by 7. We're going to clean it up a little bit. 7 over 7 is 1, so that's just y. Y is less than or equal to negative 2/7 x, and negative 7 divided by 7 is negative 1. Now it's in slope-intercept form. We are ready to graph it. So my intercept is negative 1. My slope is negative 2/7, so I'm going to go down 2 and right 7. Remember to go down and right so that you end up with a negative slope. I'm going to reverse that. I'm going to go up 2 and left 7. And then I need to look, is this going to be a solid or a dashed line? Since it's equal to the line, it's going to be solid. So I'm going to draw that line. It's going to be a solid line. And now I need to pick a test point. Well, 0, 0 is not on the line, so I'm going to choose 0, 0. So 0 is less than or equal to negative 2/7 times 0 minus 1. So is 0 less than or equal to negative 1? It is not. So that is a false statement. So since 0, 0 is not a solution, I need to go on the other side of the line and shade, and then I'm going to shade it in. Okay? So the only thing different is the conversion from standard form to slope-intercept form. My next equation in standard form is 3x plus 2y is greater than 0. So I'm going to subtract 3x from both sides because I'm trying to isolate y, and I get 2y is greater than negative 3x. Now I can write the plus 0 out there if I want, but we wouldn't typically do that. So I'm going to divide both sides by 2, and I get y is greater than negative 3/2 x. So I need to graph this line. I want you to identify the slope and the y-intercept of this line and graph it, and pay attention to whether it needs to be solid or dashed. Okay, so it should be a dashed line because it does not equal the negative 3/2 x, and it goes through the origin because it was plus 0. So I cannot choose 0, 0 because 0, 0 is on my line. Okay, so you need to choose any other point besides 0, 0. I'm going to be nice to myself, and I'm going to choose 1, 1. Okay, so let's plug this in. Is 1 greater than or equal to negative 3/2 times 1? So is 1 greater than or equal to negative 3/2? Well, any positive is greater than any negative, right? So that's a true statement. So that means that 1, 1 is one of my solutions. So every other point on that side of the line is a solution, and we would shade it that way. Next, I have the equation 12x plus 8y is less than 24. So I want you to try to convert this to slope-intercept form, and then check it with a video and let's see how you do. I subtracted 12x from both sides, and then I divided every term by 8. I got y is less than negative 12/8 simplifies to negative 3/2 because 4 goes into both of those. So negative 3/2 x, and then 24 divided by 8 equals 3. Now you have a line to graph. Graph the line. Make sure you pay attention to whether it should be solid or dashed. The y-intercept was 3. The slope was negative 3/2. It should be a dashed line. And now I need to pick a test point. So I'm going to pick the point 0, 0. Why don't you plug in 0, 0 and tell me if the statement you get is true or false? When I plugged it in, I got that 0 was less than 3. That means that 0, 0 is a solution. So everything on the same side as 0, 0 is a solution. So I'm going to shade it this way. This one is done the exact same way, but there's one thing we need to pay attention to. 2x minus 6y is less than or equal to negative 24. So the first thing I'm going to do is subtract 2x from both sides, and I get negative 6y is less than or equal to negative 2x minus 24. I'm going to divide everything by what? What am I dividing everything by? I'm dividing everything by negative 6. And when I divide both sides of an inequality by a negative number, what do I need to do? I need to reverse the inequality, right? So this is going to become y is greater than or equal to negative 2 over negative 6 simplifies to a positive 1/3 because a negative over a negative is a positive, and negative 24 divided by negative 6 becomes plus 4. Okay? All right, so identify the slope, identify the y-intercept, graph this line, pay attention to whether it's dashed or solid. This should be a solid line because it can actually equal the line. The y-intercept is 4 and the slope is 1/3. So I think that's what the line is supposed to look like. We can choose 0, 0 because it is not on the line. So plug in 0, 0 into the inequality and see if you get a statement that is true. When I plug it in, I got 0 was greater than or equal to 4. That is a false statement. So 0, 0 is not on the side of the solution. That means I need to shade the other way, and that is how that linear inequality is graphed.